Hello, my name is Jean-Marc Quéré. I am a computer science engineer. I'm working on minimal processing systems and programming languages to implement collaborative agents for shared intelligence processes. The use case may vary from learning classifier system to supervised learning via video game industry. In 2020, I got interested in natural language processing and would like to try to build something new from its roots. So I was looking for a small language with simple rules that have significant versatility by using structured construction like term combination. After a little research, thanks to Google, I found links to a constructed language, Tokipona. I spent much of the year learning about it, playing with it and meeting many of its speakers, actually mostly as writers on social media. From one thing to the next, I have completed a large collection of notes on the language itself. To get a printed version of all my notes, I started writing a book on the Amazon Kindle Direct Publishing program. Amazingly, it gets sales. Then I met Sonia Long. She was working on the Tokipona dictionary and offered a help to update and improve the book with the 17 new words of Ku Suli. She kindly offered to write a preface. Thus, the latest version of Sonali 1, Ku Suli version, was born. It was the first step on a path that has brought us to this day and will continue for a long time. At least, I hope. Long life Sonia Long, the community, and of course, Tokipona. Now I am trying to take a further step to create tools that can be used to process Tokipona text and help me investigate cognitive biases using graphical data modeling in partitioned context. The first one is TPLP for Tokipona language processing. A Tokipona sentence can be split in several parts using separators like particles la, li, e, and preposition kepeken, lon, sama, tan, tawa. Each part has a function: context, subject, predicate, direct object complement, complement. This sample splits the sentence Tenpo suno pinila mi moku e kala wan lon poka seli. Yesterday I ate a fish by the fire. In a context, tempo suno pini, which answers the question when, a subject, me, who make the action, a predicate, in this case a transitive verb, moku, a direct object complement, kala1, on which the action is made, a complement introduced by the preposition lon, pokaseli, which answers the question where. The structure on the right shows the links between the different parts of the sentence. Context, subject, and predicate are linked to the root of the proposition. The direct object complement is attached to its transitive verb. The complement introduced by the preposition lon is a child of the predicate to, because more than one predicate can be used in a sentence and each one may have its own preposition. The process applied to the sentence to build the tree is iterated on each context part. In fact, the context can be a proposition with its own subjects, predicates, direct object complements, preposition, and complements. At its minimal expression, the context is considered as a self-describing subject. The sentence can have several contexts. They are always linked to the root of the tree. A special context, named conditional context, can be used. It is introduced by a comma followed by the particle la. The sentence mi pilin la milon is an example. If I think, then I exist. When the subject is me or Sina, the particle li does not prefix the predicate. Nevertheless, the Swiss structure contains a node to attach the verb to the main predicate node, PD. This slide shows the most common case with me, Sina, without li particle, and Ona. A subject may include more than one item. In this case, N is used to join them. Li is not the only particle that can introduce the predicate. O is used for the imperative form and replaces li in all cases, including me and Sina. The samples from top left to bottom right are Mimoku, I ate, Sinamoku, you eat. Ona limoku, he or she or it eat. Pronouns are not gendered and doesn't have plural. They are invariable. So by example, me can be used for me or we. Me limi and me limoku. My wife and I are eating. Yan li o moku. Children eat. The direct object complement is introduced by a and linked to the predicate, transitive verb, and the tree. A transitive verb can have more than one direct complement. In the sample, Yan li moku e kili e kasi. People eat fish and plant. Kili and kasi appear in the tree at the same level. They are children of the same node CD. Note that the preposition lon introduces a complement pocas sedi. They are attached to the node pp in the tree, and this one is a direct child of the predicate. More than one preposition can be used for each predicate. Yan lili likama sona tan lipu sama mama ona. Children learn from books like their parents. Contains two prepositions. See them in the tree. All the trees shown have been produced by TPLP for each provided sentence. Several steps are necessary to build a data structure from a text. This is a short description of how TPLP operates. Here is a description of the full process. A text is submitted. It is normalized, then cut into sentences. Each sentence is broken down into words, several of them known, some of them unknown. An analyzer builds the structure corresponding to the sentence by identifying each term of the parts, context, subject, etc. Normalize involves detecting diacritics and illegal characters. Diacritics are removed, and if the resulting character is not a letter of the alphabet, it is deleted. Otherwise, it is capitalized to identify the word as a non-Tokipona word. All words and codes are joined by an underscore or handled as a single word. Common punctuation marks are detected and used as sentence separators. The character strings of each sentence is stored in the list with the rank of the punctuation mark, 0 for period, 1 for column, etc. Subordinate clauses are introduced by ni, followed by a colon. Mi pilin e ni sinapona. The propositions are mi pilin e ni, I think that, and sinapona, you're nice. The getWordList function uses a JSON file which contains a description of all Tokipona words, QSUD, including the word itself, its usual function, and an index code. Each word of the sentence is searched in the file. All words found are known. The others are added with the negative incremental index. Nodes are created with word data and sequentially added to the word list. The analysis step is the main part of the process. It traverses a sequence of nodes representing the sentence to identify the different parts: context, subject, predicate, direct object complement, preposition, and complement. It begins by the context, là, then search the subject which leads to the predicate. Each predicate can be associated with one or more direct object and preposition. This is a typical use case. Toki ike alala kalama musi sina enselo wazo sina lisama. La sina wazo sewi tan mapikasi suli. The tree produced by TPLP is shown below this sentence. The P particles rules words grouping for noun and adjective. It factories the terms see note about P. The next goal is to connect pronouns between sentences to produce the additional data needed to answer the questions involving this type of resolution. The objective is to study the implication of the order of the prepositions and the impact of the context on the resolution processes. What is implicit, what is explicit, how can biases and different cognitive representation emerge from the same communication? The TPLP project raised a lot of expectations. First, market can be improved and processes simplified as much as possible. Then the data structure can be stored in the database with axes, timeline of events per speaker, relation and place mapping, concept node maps. Data translated in Tokipona, if necessary, from various sources, web pages, social networks, search engine results, titles of newspaper articles, are extracted manually or collected in automated way to feed a database. The database contains many prefigured contexts. One of them, or a combination of them, is preluded to change the point of view of data loaded from external sources. Natural language querying, using Tokipona, receives information from the database. The result may change depending on the query expression and the preloaded context, or context combinations. The difference between the results permit bias detection and analysis. This step is still a work in progress. Big shout for your support and special thanks to Sonia Long, Jeffrey Snape, Howard University, readers of Sonali One, Facebook friends in the Tokipona groups, and all others who have survived my Tokipona addiction. Sina kute e makepeken Tokipona la, sina ken lukin ante eona. O Tokipona a. Thanks for watching.